Alright, in this video we're going to look at two examples of a recursively defined sequence, and then we're going to go ahead and write out the first 7 terms of this recursively defined sequence. And so with recursively defined sequences, I need a starting point, or I need to know the first couple of terms of the sequence, and then from that maybe I add the first 2 terms and then continue some sort of pattern like that. In this case, in the one we have on the screen here, A1 is equal to A2 is equal to 1. And then how I get the third term is I add the previous 2 terms. To get the third term, add the previous 2 terms. This is actually called the Fibonacci sequence. And this sequence is this recursive definition works as long as n is 3 or larger. So if we write the first 2 terms, 1, 1, to find the third term, I have to add up the previous 2 terms, which is just 1 plus 1, which is 2. Okay, to find the fourth term, add up the previous 2, so the third term and the second term. So 2 plus 1 is 3. To find the fifth term, we'll add up the fourth term and the third term. So 3 plus 2 is going to be 5. And the sixth term will be the fifth term plus the fourth term. So 3 plus 5 is going to be 8. And then we are just going to go up to the 7th term, so you can go as far as you want. The 7th term is going to be the 6th term plus the 5th term, which will be 8 plus 5, which is 13. Okay. All right. So let's go ahead and look at another one here. Let's say that the first term is defined to be 1. And then to get to the next term, we have to multiply the previous term by 2. Okay, so we'll put in 1. To get to A2, we need to multiply A1 by 2. So we got 2 times 1, which is going to be 2. So in a sense, we're just doubling the next term. And then the next one will be 4, and then 16, and then 32, etc. So you're just multiplying the previous term by 2. Now this isn't the only way that we could write this recursively defined, this sequence. Not necessarily it has to be recursively defined. It looks like it's probably going to be a geometric sequence because we are multiplying each term by 2 to get each individual term in the sequence. But as you can see, the pattern continues here. I think we're going to go all the way out to 64 here with the 7th term. Okay, so that's your recursively defined sequences. You'll have to know the first couple of terms, and then you just need to use that formula, and that formula you just build upon to get to your next term. Just keep building on top of what you know.